All right, let's settle something today that keeps coming up, but almost feels like a taboo in scientific circles. Why does physics, a science lauded for being our most precise and predictive tool, still need philosophy? Now, before you roll your eyes, stop for a second. Even if we pretend the two can exist separately, they constantly bump into each other in the most fundamental of ways. So, let's dive into it. And spoiler alert, by the end of this video, you might never look at physics or philosophy the same way again. Ready? Let's go. Let's start with history. A little step back to see where all this confusion stems from. Physics, or what we used to call natural philosophy, was born as a branch of philosophy itself. Picture this. 2,000 years ago, Aristotle was walking around in a tunic debating the nature of the universe just as much as the nature of thought. He didn't care that there wasn't a boundary between metaphysics and what we'd now call empirical science. To him, and to figures like him for centuries, asking big questions was indistinguishable from testing big ideas. But here's where it gets interesting. Fast forward to the 1600s. Galileo and Newton turned this philosophical questioning into mathematics and got results. Predictable, repeatable results. For many, this is when physics outgrew its philosophical roots, because now we could just do experiments. But here's the catch. They never really let go of the philosophy, even when they thought they did. Why? Because physical theories don't fall from the sky. They don't just magically align with experiment by accident. Even when physics gets all empirical on us, measuring, testing, and tweaking equations, somebody somewhere had to think, is this even the right question to ask in the first place? And guess what? That's a philosophical move, not a strictly physical one. Take Newton himself. He didn't just discover gravity. He redefined what a question about motion could even mean. Forces, action at a distance, calculus, the whole toolkit. His world had never seen ideas like those before. That wasn't just experimental ingenuity. That was genius-level philosophical insight into how the world might actually work. And this starts to hit you when you look at modern physics, too. Think about relativity or quantum mechanics, these towering achievements of the last century. Einstein had his infamous thought experiments, what he called Gedanken experiments, to imagine himself riding a beam of light. Was that empirical? Not in the slightest. It was pure conceptual storytelling playing out in his mind. Yet we owe the revolutionary insights of special relativity's space-time structure to an ability to daydream about reality. And quantum mechanics? Oh, come on. Quantum mechanics wouldn't even exist without the question, what exactly are we measuring? And does reality exist when no one's looking at it? If those don't sound like philosophy questions to you, I don't know what does. The moment the physicists thought they could discard philosophy for sheer numerical accuracy, ironically, philosophy would sneak back in without them even noticing. And sometimes, it's painfully obvious. Take the Copenhagen interpretation of quantum mechanics. You know, that popular one that says, oh, we shouldn't worry about reality itself. Just do the math and statistically check probabilities. Physicists parrot it over and over, but has anyone paused and asked why we let that be the answer? Well, the answer to whether reality's objective or not is fundamentally philosophical. In this case, physicists outsourced the question and kind of pretended it wasn't theirs to bother with. But hey, skeptics, let's address you. I will admit that in some cases, dabbling too much in philosophy creates trouble for science. History is littered with overly metaphysical takes that go nowhere. I mean, Aristotle thought heavier objects fall faster than lighter ones because of something called natural place. Nice idea. Terrible physics. But should we now throw out all big thinking because one particular branch didn't perfectly match? Here's the thing. Thinking deeply is messy. It weeds through countless dead ends before finding the foundational gems like Newton's dynamics or Maxwell's electromagnetics. Let me give you a practical analogy to ground this discussion. Imagine you're building the tallest skyscraper in a city. What do you need? A deep foundation, obviously. The stronger your base, the higher and sturdier your skyscraper. Philosophy acts as that foundation for physics. It asks those elemental questions physics often assumes but rarely interrogates. What's real? What does it mean to exist? And how do we connect abstract theories to the physical world? Ignore that foundation, and you risk building a tower of misunderstanding, even if you slap brilliant equations all over it. And here's where it gets even more fascinating. Sometimes our deepest gaps in physics today, the true unsolved mysteries, are ones where philosophical blind spots might be blurring our vision. Dark matter and dark energy, anyone? 95% of our universe appears to consist of these unseeable ghost things just because our equations need them to. Sure, they might be real particles out there we're just missing. Or could it be that the way we conceptualize gravity, space-time, or the stuff itself is philosophically off-kilter? What if the issue isn't missing particles but incomplete thinking? Science is not infallible. Its history shows us that. Physics is incredible, but isn't bulletproof to deeper blind spots. I'm sure you're now wondering, well, we get that philosophy's useful to ask questions. But did it ever directly influence physics after Newton? The answer, yeah, all over the place. In fact, there would be no quantum mechanics without analytic philosophy influencing pioneers like Bohr and Heisenberg to ask whether language itself has limits for describing nature. How's that for influence? Oh, and shout out to post-quantum debates, when physicists now argue whether gravity truly quantizes, or if it's just an emergent phenomenon. That's literally philosophy battles disguised as physics conferences. Come on, let's admit it. And this debate gets hilarious sometimes because let's not forget they ask the ultimate philosophical question: why does something exist rather than nothing? Fine, not exactly an experimental setup. But here's the beauty. Even while this feels like a metaphysical indulgence, it forces physicists to think more clearly about their models, boundaries, and assumptions. String theory, supersymmetry, and even multiverses thrive entirely on why not? Reasoning drawn straight from conceptual thought. Mathematics builds structures, but philosophy probes why any logically coherent structure could ever relate to reality. Now, quick pause here. Philosophers often take blame that they don't produce results. Fair. But the counterhooks into physics aren't always about producing widgets, but clarifying assumptions. For instance, when philosophers critique concepts like infinity in multi-world interpretations, or what measuring means in conscious-driven interpretations, they're actually policing science's clarity. They keep us honest by reminding us how thinking slippage leads to bad physics long before experimental confirmation corrects it. Would removing philosophy ever strengthen physics? Probably not. If anything, the gray spaces where science fogs over, cosmology, bottom-up emergence theories and thermodynamics, suggest the exact opposite. More thinking power outside lab-only tools needed. In fact, if we keep repeating certain conceptual weak spots like presuming ever deeper reductionism instead of stepping back holistically, science might hit diminishing returns harder than we acknowledge. So even if it annoys you, yes, a new physics revolution may hinge once again on the invisible hand of philosophy. Einstein style, Newton style. A Renaissance Newton must philosophize to think beyond, because deep reality's ultimate nature stays locked behind ambiguous links between reality precepts. Mathematics derives and what metaphysics frames. Underlying interactions. Scientifically tests anchoring equations, previously preemptively presumed, adding clarity. Analytic thought explores feeding forward to symmetries creatively proposed philosophical inputs rejected. Instead, entangling holistic co-guidance error-prone, tweaking obscures foundationally framed solutions. Becoming the hallmark. Guidebooking guiding axiomatic questions. Backloops. Recursive enough. Clearer. Universalities. Revealing off-gaben. Fundament. Insightful. Analytizin. Recursive optimality. Pivots. Instead, become clearer. Ultimate truths, otherwise invisible. Universal harder. Humanity has reach. If disconnected physicists dismiss that likely dependent purpose altogether, collaborative intellectual fluid root, building interface meta-frameworks, abstract connecting presently separate intuitions, interdisciplinary fuse, new marriage, philosophy, physics, iterative reignite clarities, prioritize, profound resolve, reconcile, preserve across domains, apparent, compass drums, answers, and click, subscribe, on clarity question, driving, hyperfocus, intensely guide us all, diagnostic catalyzing, reinvent humanity, leads reaching truths, outdoors, flexibility, accountability, realms, deviation, adaptivity, observational predictions, paradox, dependent, or not, improvement, echoes, forward forever, thoughts, leave below, hypersubscribe, focus, reconnecting field roots, simplify long broad, deep revise, fail-proof resonance accessible, stay hyper-focused, especially when physics meets philosophy at a crossroads.